Hello students of the internet. As you most likely know from doing GCSE Geography, a river is made up of three courses, the upper, middle and lower courses, running from source to mouth. It is made up of many different tributaries, joined by confluences. Now you know those terms, I can inform you about the Drainage Basin Hydrological cycle. Wherever you are, at home or at school, you'll be on a drainage basin. A drainage basin is an area of land drained by a river and its tributaries. They are separated by ridges of higher land, called watersheds. Any precipitation falling outside the watershed will drain into a neighbouring basin. Geographers use a part of systems theory as a way of explaining the hydrological cycle. The theory is often classified into three types: isolated systems, where there is no input or output of anything; closed systems, where there is no input or output of matter; and open systems, where there are inputs and outputs of matter. An example of a closed system is the water cycle. As no water enters in or out, it simply circulates the cycle. An example of an open system is a river, where water enters via the input of precipitation and leaves at the mouth or via evapotranspiration. When inputs and outputs are balanced, the system is said to be in a state of dynamic equilibrium. When visualized as a flow diagram, the drainage basin's open system is more easily seen as a combination of inputs, stores, flows, and outputs. The inputs are precipitation, outputs being evaporation and transpiration. Examples of stores are surface storage such as puddles and lakes, soil storage, and groundwater storage. The transfers and flows of the drainage basin are infiltration, the downward movement of water into the soil surface; percolation, the gravity flow of water within soil; overland flow; and through flow, the movement of water downslope within the soil layer. The balance between water inputs and outputs of a drainage basin may be shown as a water budget graph. The equation for water budget is precipitation equals runoff plus evapotranspiration plus the change in storage. In a temperate climate, like here in the UK, precipitation usually exceeds evapotranspiration over the year, so there is a positive water budget. In the winter, when evapotranspiration drops and precipitation increases slightly, there is a water surplus. Whereas in the summer months, when there is more evapotranspiration, soil moisture utilization occurs. However, once there is more precipitation, soil moisture recharge will happen. Here you can see me drawing hydrographs for two types of river. These hydrographs can reveal how rivers respond to a single rainfall event and examine the relationship between rainfall and discharge. Flashy river hydrographs tend to have a short lag time, high peak, and steep rising limb, whereas flat rivers have a long lag time, low peak, and a gently sloping rising limb. You may have not heard the terms flashy and flat rivers. Flashy rivers are rivers with small, circular, wet, and steep-sided drainage basins with a high drainage density. This creates large sudden increases in discharge that give it the name of flashy. Flat rivers, however, have large, elongated, gently sided, dry drainage basins, so have a low drainage density. Rivers tend to have many changing channel characteristics. However, first we must be aware of the river processes that can be divided into three groups: erosion, transportation, and deposition. There are 5 types of erosion you need to know of. Abrasion or corrosion, which is the scraping, scouring and rubbing action of bedload, wearing away the banks in bed. I remember this due to some of the word able being an abrasion, and abrasion being the only type of erosion able to break the bed. There is also attrition, which is the reduction in size of sediment particles as they collide with each other, the beds and banks, making sediment small and rounded. The third type of erosion is hydraulic action, which is the power of moving water. removing material due to friction or drag. I remember this due to the word hydro, a word for something related to water being in hydraulic action, and its meaning being to do with water. The fourth type you have to remember is solution or corrosion, which is when minerals are dissolved in water, creating a chemical change. The final type is cavitation, which is when bubbles form in water as velocity increases. If the bubbles implode, tiny jets of water are evicted, which can hit the bed and banks at speeds of up to 130 meters per second. You may be wondering what causes river erosion. You're in luck, because that can be answered. Rivers erode because they possess energy. Energy of a river is affected by many factors. These are that the greater the mass of water, the higher the source above sea level, and the steeper the channel, the greater the energy. It is also important to know some of the energy is used up to overcome friction by turbulence with bed and banks. Erosion of a river can be categorized into three different types. Vertical erosion, which occurs in the upper course, near or at the source. It is where the water in the river is trying to cut down to sea level due to gravity. The second is headward erosion, which is the river eroding back towards the source. An example of this is waterfalls and rapids, which erode backwards to smooth out a concave gradient for the river to flow down. The final type is lateral erosion, which occurs in the middle and lower courses, closer to sea level. The river widens the valley when this type of erosion occurs. These types of erosion create very different channel shapes. The channel shape is often expressed by its hydraulic radius, which is the ratio between the cross-sectional area and the length of the wetted perimeter. The cross-sectional area is measured by calculating the width and mean depth of the channel. The wetted perimeter is the total length of the bed and bank sides that are in contact with the water in the channel. I have gone on a huge tangent, but hopefully given you all the knowledge on erosion in rivers. If you can remember, we were talking about the three processes: erosion, transportation, and deposition. Like erosion, transportation can also be categorized into four types: traction, which are large boulders and rocks that are rolled along the riverbed; saltation, which is where small pebbles and stones are bounced along the riverbed; suspension, where fine light materials are carried by the river; and solution, where rocks dissolve into water and are carried away. When discussing transportation of sediment load, it is useful to distinguish between the two terms, competence and capacity. Competence is the maximum size of load a river is capable of transporting, whereas capacity refers to the total volume of sediment a river can transport. Velocity greatly affects both of these. This is because when there is a low velocity, only fine particles are transported, whereas at high velocity, larger rocks are transported. The Hjulstrom curve illustrates the relationship between velocity and competence. It shows the velocities at which sediment will normally be eroded, transported, or deposited. As you can see from the Hjulstrom curve on screen, the smallest particles may never be deposited, and will only be put down in estuaries. This is called flocculation. You can also see that sand particles are more easily eroded than clay or silt, which are more cohesive. Velocity at which particles can be picked up is called entrainment. Once entrained, particles can be transported at lower velocities than those required to pick them up. The critical velocity is the velocity at which particles can no longer be carried. The third river process we need to talk about is deposition. A river deposits when it is no longer competent or has the capacity to carry all of its load. Any reduction in velocity will reduce the competence and material will begin to be deposited, starting with the coarsest sediment first, as this requires a lot of energy to remain in suspension. There are many factors that might decrease velocity and therefore increase deposition. These are when a river enters a lake or sea, a decreasing gradient, droughts, floods, the inside of meanders, unstable banks, and flows over permeable geology. All channel characteristics can be expressed in the Bradshaw model, which is a handy way to visualize changes in the river as it gets further downstream in an exam. Another way to help with visualizing changing gradient is to draw a long profile. A long profile shows the changes in altitude downstream. The generalized diagram expresses a smooth concave shape called a graded profile. However, rivers' long profiles are rarely smooth, with irregularities such as waterfalls. Along with long profiles, cross profiles of rivers are drawn. Cross profiles change as you go down the river. In the upper course, due to mostly vertical erosion, the cross profile is very narrow and steep-sided. As you get further along the river, however, the cross profile tends to get wider. Along with long and cross profiles, valley profiles are used. In the upper course, the valley profile is also steep-sided, with the valley floor being the river. Whereas in the middle course, floodplains often are created along with distinct bluffs. At the lower course, the valley profiles are so wide that the valley sides are often very hard to locate, with very large flat floodplains. I will now be describing the landforms and rivers in the Drainage Basin Hydrological cycle. The first landforms I will be talking about are V-shaped valleys and interlocking spurs. In the upper course of rivers, as we have discussed, there is lots of vertical erosion. This produces a very steep-sided V-shaped valley, although its exact shape does depend on three factors, those being climate, geology, and vegetation. Interlocking spurs are also a characteristic found in the upper course of rivers. These appear when the river winds around hills or ridges. Another landform I'll be informing you about are rapids. Rapids are found where there is a sudden increase in the slope of the channel, or where the river flows over a series of gently dipping, harder bands of rock. A waterfall is a sudden fall of water that occurs when there are rapid changes in gradient in the river's course. They are most often found where there are changes in geology in the river valley, where less resistant rocks are found above more resistant rocks. The plunge pool at the bottom of a waterfall experiences very rapid erosion. This undercuts the less resistant beds behind the waterfall, leaving it prone to collapse. This is why waterfalls retreat upstream, often leaving a gorge behind them. A smaller landform I'll be telling you about are potholes. These are found in the upper course of the river and are created by vertical erosion cutting into the bedrock. Over time, this erosion creates small depressions in the riverbed. After this, the depression is deepened and rocks called grinders get stuck in the pothole and drill into it in a circular fashion. This is the process that creates potholes. The landforms I have been describing to you were erosional, so are caused by erosion. Now I will inform you of depositional landforms found in a river. The first ones I will describe are floodplains. These are very flat areas of land that are often covered when flooding occurs. However, they are often very fertile, as successive floods add to the alluvium on the plain. The next type of landform I'll describe are levees. On some rivers, the dropping of coarser material during floods can lead to levees. These are banks of sediment running parallel to the river. Levees are often artificially strengthened, like they are on the Mississippi in the USA, to prevent flooding. Another depositional landform is braiding. In rivers where there is high amounts of sediment, braiding may occur. When water levels fall and energy decreases, this large amount of material can be deposited, so much so that it can block the main channel. This leads to smaller channels being created that divert around the sediment. Another landform I will describe is a delta. These occur when sediment is deposited at the mouth of a river, when it enters a slow-moving body of water, such as a sea or lake. There are four types of delta: an arcuate delta, which is a rounded convex outer margin. An example of this is the Nile. A cuspate delta, which is where material is evenly spread on either side of the estuary. A lobate or bird's foot delta, which has many sediment-bound distributary channels, which extend out in a fan shape. An example of this is the Mississippi. And last but not least, the estuarine delta. When a river attempts to find the quickest and least resistant route to the sea, it often forms the landform known as a meander. On the inside of meanders, you often see deposition. which is why I've talked to you about it among all the other depositional landforms. However, it is important to note that there is erosion on the outside of meanders. Meanders are often described as a sinuous bend. This is because a river bend is only classified as a meander when it reaches a sinuosity index greater than 1.5. To find the sinuosity index of something, you divide the actual channel length by the straight line distance. Meanders are formed due to the flow of water in a river, avoiding shallower areas called riffles. The flow of water instead follows the fastest route. This is called the Thaweg line. Meanders create two landforms themselves. If you remember earlier, I said that meanders erode on the outside and deposit on the inside of the curve. The erosion creates a landform called river cliffs, whereas the deposition creates slip-off slopes. This deposition is also aided by the helicoidal flow in the river. In the long term, meanders can create another type of landform, called an Oxbow lake. These occur due to erosion on the outside bend of a meander. This erosion can join two bends of a meander, leaving one bend excluded. It's also worth knowing that this process is often aided by flooding. Eventually, the river will stop flowing through the excluded bend, making it a lake. The last thing I will talk to you about rivers and everything else in the drainage basin hydrological cycle is rejuvenation. To explain rejuvenation, it is probably worth briefly going over some of the facts I have said in this topic, and that is, a river is always trying to reach a state of equilibrium and to create a smooth concave profile. As you know from watching me talk about this topic, however, occasionally something destabilizes the situation, so the river has to actively erode to re-establish equilibrium. This is called rejuvenation. Rejuvenation can change the long profile of a river completely. First, for this to happen, you need a fall in base level. This may occur due to a fall in sea level relative to the land. This is a eustatic change, or a rise in land relative to sea level, which is called an isostatic change. Once one of these changes happen, a waterfall by the sea can be created. This, as you know from when I covered waterfalls, is a nick point. When rejuvenated, a nick point will start at the sea and gradually work its way back up along the river course. The speed at which it goes upstream depends on the resistance of the rock.
Hi, this is Seb from Revise. Don't forget to comment, like, share and subscribe if you enjoyed the video. And remember, keep revising!
Revise, revision expressed virtually and internationally to supplement education.